Okay, in this class I'm going to just start thinking about the equation of a line, and really we're only going to go through two particular kinds of lines in this class and what their equations look like. But before I do, remember, and this is not new, or it shouldn't be new, some collections of points follow a particular rule allowing us to express one coordinate in terms of the other. These collections are sometimes called loci. The singular of that is a locus of points. So for example, we know that if the y coordinate is equal to some quadratic in x, so in other words we've got an x coordinate and then we have some function that's quadratic, so ax squared plus bx plus c, for example. We know that those functions all look like this or this. These are parabolas. So if the y coordinate can be expressed as a function of the x coordinate where that function is quadratic, then the shape of the graph, if I was to plot all the points that satisfied this, we have an x coordinate and the y coordinate is just some quadratic function of the x coordinate, we would have this. So if I had, for example, the y coordinate was equal to x squared, we would have the point 0, 0 there, 1, 1, 2, 4, 3, 9, negative 1, 1, negative 2, 4, negative 3, 9. So, quadratic functions generate parabolas. If the y coordinate can be expressed as a cubic function, well then we're getting some kind of shape like that. And again, we looked at that before. And if y can be expressed as a linear polynomial in x, well then what we're going to have is, I suppose, one of four different things. We could have an increasing straight line or a decreasing straight line. We could have a horizontal line, or we could have a vertical line. And in this class we're going to talk just about the last two there, horizontal and a vertical line. So suppose I want to graph the line. I want to think about the line where the equation of the line is just y equals 1. What does that mean? Well, that means that every point, every point has an x coordinate and a y coordinate. We know that. But in this case, the y coordinate they're telling me is always 1. So what does a collection of points look like where the y coordinate is always 1? Well, there's my y-axis and my x-axis. If the number 1 is there, every point that has a number 1 as its y coordinate will be on this line. So that line is called the line y equals 1. So that's the equation of the line. Sometimes we give those lines names. We might call it line L. If we do, you'll often see it written like that, L colon y equals 1. That just means the name of the line is L and the equation of the line is y equals 1. Suppose I look at the line where every x coordinate is equal to 2. And again, just remember, every point has an x coordinate and a y coordinate. But this equation is saying that we want to look at a line where the x coordinate is always 2. What does that look like? Well, again, just go to your axis, go out 1, 2. There's where the x values are 2. Every point with an x value of 2 will be either directly or above or below 2 on the x-axis. So every point on that line has an x coordinate of 2. So the name of that line might be x equals 2. Sorry, the equation, I should say, of that line would be x equals 2. And again, we might give it a name. I don't want to call it L again for line because I call this one L. So I might just call that one L1 and maybe I'll call this one L2. Okay, but I could call them A and B. There's no particular reason to use the letter L. We look at y equals -1. Again, remember every point looks like this, x comma y. This is telling me y equals -1 is the collection or the locus of points where the y coordinate is always equal to -1. And thinking visually, I'm going to look, where is the y coordinate equal to -1? Well, it'll be below the x-axis down there. And every point, all the points where the y coordinate is equal to -1 will be along there. So that is the line with the equation y equals -1. And again, I might give that the name L3. And then finally, x equals -3. Well, that's the collection of points where the x-coordinate is always -3. The y-coordinate will change, but the x-coordinate is always -3. And if I look at the collection of points where the x-coordinate is -3, this is not done perfectly to scale or anything like that, it'll be a vertical line passing through the x-axis at -3. And that line will have equation x equals -3 because the x-coordinate is always just -3. And maybe I'll call that L4. Okay, so that's introducing the equation of a line. So the equation of any horizontal line is y equals a constant. And the equation of any vertical line is x equals a constant. Notice if it's a horizontal line, the slope of the line is equal to 0. If it's a vertical line, the slope is undefined. And that's again stuff we've mentioned before. Vertical lines have undefined slopes. Horizontal lines have slopes of 0. The equation of any horizontal line is y equals a constant. And the equation of any vertical line is x equals a constant. So here's something I'm going to encourage you to do as opposed to use your textbook. Use the slider function to generate horizontal and vertical lines in GeoGebra. So let me try to do that now. I'm going to try to use the slider function here to do that now. Generate horizontal and vertical lines in GeoGebra.